Good morning, students. Yesterday we studied about differentiation, right? I have explained to you how differentiation is to be done. Roots and other things have been explained. Today I am coming with integral calculus. Integration it is called. Integration is a reverse of differentiation, right? In through differentiation, we get the small value of a quantity. Small value of a quantity means dy by dx. Dy by dx means this very small change in the value of a function, in the value of a depending variable. When there is a small change in the value of the independent variable, we can say that dy is the very small value of a quantity that can be obtained using differentiation, right? For example, I say, suppose y is equal to x cube. Y is equal to x cube. If I write so, then what is the differential coefficient of this quantity? That is equal to dy by dx is equal to x cube, we can write. From this relation, we can obtain dy. dy is equal to x cube into dx. This x cube into dx is what is called a dy. What is dy? dy is the very small value of the very small change in the value of the depending variable or the function. Y is the function. The small value of the function you are getting, that is this one. So from differentiation, actually what we are getting is the very small change in the value of the function we are getting, right? Now, through integration, from this very small value of the function, we can obtain the whole function itself, the value of the whole function itself. That is why it is called the reverse of differentiation. Integration is that what is called the reverse of differentiation, right? So this one x cube into dx, when I write, this is what is called dy. Dy means it is a very small change in the value or very small value of the function. If very small value of a function is a function we know, knowing that value, the whole value can be obtained by integrating that. Dy when integrated, we will get y. What is y? Y is the whole value of the function. I can say like this now. This is this line what I made on this board. This is read as integral, right? When I write in dy also here, this is integral dy you will call today onwards. From today onwards, we will call this sign as integral. When I write like this as a whole is read as integral dy. Actually, integral dy is equal to y only. Y is a sum of small values of y. Small values of y means dy plus dy plus dy plus dy plus dy plus dy. That is equal to y. Actually, integration is summation of small values to get the whole value of a quantity. This is called integration. So integration is summation. Integration is the reverse of differentiation. Through differentiation, we get small value of a quantity. But through integration, we will get from the small value of a quantity, the big value, the whole value can be obtained. This is the best example, best way of explanation I can make. I'm writing an example here. Let y is equal to x raised to 6. This is the function. Okay, nice. I am writing the differential coefficient of this function, that is dy by dx. Dy by dx, because y is a function of x, hence that function can be differentiated with respect to x. That is dy by dx is equal to what we will write, that is equal to d by dx of what is y? Y is equal to x raised to 6. X raised to 6. Am I correct? So this is in the form of integral. Yesterday we have said integral x raised to n dx is equal to n into x raised to n minus 1, right? N into x raised to n minus 1. This is the rule. Our rule, how it is operated in differentiation. X raised to n, sorry, dy dx, sorry, dy, dy dx of x raised to n is equal to, the rule is changed, okay, no problem. D by dx of x raised to n is equal to n into x raised to n minus 1. I'm sorry, right? N into x raised to n minus 1. Right? So this is also the form of x raised to n only. So hence what we can write this as in the place of x, in the place of n, here we have 6. Therefore, this is written as equal to 6 x raised to 5 we can write. This is the differential coefficient of the function y is equal to x raised to 6. Okay, very simple, right? Therefore, dy is equal to what? Therefore, dy is equal to 6x raised to 5 into dx. In the differential of a small value, there is dx is here. This value is dx by dy by dx. dy by dx into dx is equal to only dy. What is dy? dy is the very small change in the value of y. So now we have dy, you know. Knowing dy, we can get back y is equal to x. So they see that how it is obtained. Now I am integrating this function. This dy is integrated. That is integral dy is equal to integral 6 into x raised to 5 dx. Don't forget to write dx. Then only this, the whole thing is dy. Integral dy must be equal to y. Y is equal to x raised to 6. You must get. Am I correct? Okay. So when a constant is there, always the constant can be taken out. This is equal to 6 into integral. How it is said? 6 into integral x raised to 5 dx you can write. Right? As a rule, I tell you, integral x raised to n dx is equal to x raised to n plus 1 divided by n plus 1. There's a rule there. Rule I will tell you afterwards. In this class only, I will say this is the rule. Integral x raised to dx is x raised to n plus 1 divided by n plus 1. But differential of x raised to is equal to n into x raised to n minus 1. These two rules are also important. Okay. So in integration, power rule is applied like this. Integral x raised to n dx is equal. This is dy, right? That is equal to in x raised to n plus 1 divided by n plus 1. In the same way, how this is operated? This is equal to 6 into, when the thing is integrated, that must be kept in the square bracket. That is x raised to 5 plus 1 divided by 5 plus 1. X raised to n plus 1 divided by n plus 1. When integral x raised to n dx, if integrated, we will get x raised to n plus 1 divided by n plus 1. Here in place of x raised to, we have x raised to 5. That's x raised to 5 plus 1 divided by 5 plus 1. This is the rule. So what we get? This is equal to 6 into x raised to 6 divided by 6. 6 and this cancelled. That is equal to x raised to 6. What we are getting? This is y. Integral dy is equal to y. Y is equal to x raised to 6 only. When we differentiate it, we get the small value. When we integrate it, we get the big value. That is why this is what is called reverse of differentiation, right? It is the reverse of differentiation, right? So very simple point. There are two types of integration. One is called a definite integral and other is called a indefinite integral. So within fixed values, in a limit of fixed values, a lower limit and upper limit, if a small value is integrated, that is called a differential. Definite integral is called. For example, I tell you integral 0 to pi sin x dx. Integral 0 to pi sin x dx. Sin x dx means it is dy. It is integrated within a limit. Within that limit you had to integrate. Then this is what is called a definite integral. If this 0 and pi are not there, the lower limit and upper limit are not there, then this is called indefinite integral. So integration can be done in two ways, by what is called definite integral basis and also indefinite. In indefinite integration, there is no limit in the integration. But in definite integral, there will be a fixed limit. One is lower and the other is upper. So these are the things about. Right now, some important formulae related to integration. This is the last class I am teaching in mathematical tools. Then I will be going to physics tomorrow itself, that is what we call linear motion or motion in a straight line. I am going to. So we will discuss so many things in that class also, right? About velocity, acceleration, right? Then displacement time graph, velocity time graph, acceleration time graph, everything. Then equations of motion, right? Linear equations of motion, uniform motion, non-uniform motion, everything you will discuss tomorrow. Important formula integration. First one I am writing is integral 1 dx is equal to x only. Integral 1 dx can be written as simply integral dx also we can write. Integral dx, integral 1 dx is equal to integral dx is equal to x. Right? Second one I am writing the same thing. What is that? Integral x raised to n dx. What is x raised to n dx? That is dy. That when integrated we are getting y. So this is equal to what? Integral x raised to n dx. Now onwards, by heart. These are the things must be kept in your whole life. Remember every time. Keep in the memory bank. Right? Integral x raised to dx is equal to x raised to n plus 1 divided by n plus 1. Very, very important. For example, what I said, integral, x raised to 5 dx. Integral x raised to 5 dx is equal to what? X raised to 5 plus 1 divided by 5 plus 1. That is equal to x raised to 6 divided by 6. That is simple, right? This is integration. The simplest operation only we need, right? We are not going so much detail into this, right? Okay, this is the condition. Next is this is 1, this is 2, and this is 3. Integral 1 by x dx is equal to log x to the base e. Because differential of log x is equal to differential coefficient log x. Yesterday I gave it that. Differential coefficient of log x is equal to 1 by x. Differentiate this log x, then you will get 1 by x. Right? Rule. Right? Therefore, integration of 1 by x must be just opposite to that. That also done. Again, fourth equation. That is integral e raised to x dx. E raised to x dx means there is no change. E raised to x only exponential functions when integrated or differentiation, there is no change. Right. Next is very important. This is trigonometrical integration of trigonometrical functions that I am writing. Integral sin x dx. Integral sin x dx is equal to minus cos x. Very important. You have to by heart this. Very, very important. Yeah. Or next is this is 4.